How to find exact values for 60-degree reference angles. The background information is the same as it was for 30-degree reference angles, so if you don't need to watch that part, you could fast forward to the procedure, but I'll go through it quickly. So imagine that we have an equilateral triangle. An equilateral triangle would have all three angles measuring 60 degrees and all three sides the same length. I'm going to say the lengths of the sides are 2x. Now imagine that I drop a perpendicular from one angle across to the opposite side. That's going to cut the opposite side in half because of the nature of an equilateral triangle. And so that half length there is x. Now if we just focus on one of the sides of this triangle, suppose we focus on that side, we have a right triangle with a 60-degree angle and a 30-degree angle, and the sides that we know so far have length x and 2x. So the short leg is half the hypotenuse. And if you use the Pythagorean theorem, you can figure out that the long leg is x square root 3. The short leg is always across from the 30-degree angle, and the long leg is always across from the 60-degree angle. So that's going to be the basis for what we do to find exact values for 60-degree reference angles. Okay, now imagine that you're asked to find the sine of 60 or the tangent of 60 or some exact value for 60 degrees, and you're not supposed to use your calculator. You're just finding the exact value. So what you're going to do is start by drawing a coordinate system, and then you put a 60-degree angle in standard position. So you go counterclockwise. So there's about 60 right there. And from there, we want to drop a perpendicular to make a reference triangle. And because it's a 90-degree angle there in the corner, we have a 30, 60, 90 triangle. And we know that a 30, 60, 90 triangle always has its sides in the ratio 1 to square root 3, where the 1 is across from the short, or from the small angle, 30, and the square root 3 is across from the 60-degree angle, and the 2 is on the hypotenuse. That's always true for a 30, 60, 90. So you draw that triangle, you label the sides, and then you're ready to compute all of the exact values. So the sine of 60 would be opposite over hypotenuse square root 3 over 2. The cosine of 60 would be adjacent over hypotenuse 1/2. The tangent of 60 would be opposite over adjacent square root 3. The cosecant is the reciprocal of sine, so that would be the hypotenuse over the opposite, 2 over square root 3. Rationalize it, and you get 2 square root 3 over 3. The secant would be the reciprocal of cosine, so hypotenuse over adjacent, and that gives you 2 over 1, so 2. And the cotangent is the reciprocal of tangent, so adjacent over opposite, 1 over square root 3. Rationalize it, and you get square root 3 over 3. Next, let's imagine that we had to find an exact value for 120 degrees. If you draw the angle 120 degrees in standard position, we'll say that's about 120. That's going to leave you with a 60-degree angle made with the horizontal. Your reference triangle always includes the angle that's made with the horizontal. Drop a perpendicular, and there you have a 30, 60, 90. So always put the 1 across from the 30. Even if your triangle doesn't look perfect, like mine doesn't really look to scale, but always across from the 30 you have the 1, the shortest leg. Always across from the 60 you have the square root 3, the longer leg, and always on the hypotenuse you have a 2. The biggest mistake I see people make is mixing up where they put the 1 and the square root 3. Okay, now because we went in the negative direction horizontally, we want to put a negative on our 1 to indicate direction. And now we're ready to compute all the exact values. So sine, opposite over hypotenuse, square root 3 over 2. Cosine, adjacent over hypotenuse, negative 1/2. Tangent, opposite over adjacent, square root 3 over negative 1, so that's negative square root 3. Cosecant, hypotenuse over opposite, that would be 2 over square root 3. Rationalize it, and you get 2 square root 3 over 3. Secant, that would be hypotenuse over adjacent, 2 over negative 1, so that's negative 2. And cotangent, that would be adjacent over opposite, negative 1 over square root 3. Rationalize it, and you get negative square root 3 over 3. Okay, now let's imagine that you had to find one or more exact values for 240 degrees. So draw a 240-degree angle in standard position. It's going to go all the way around counterclockwise to about there. So that whole thing is 240. Make the perpendicular to make the reference triangle, and inside the triangle the angle is a 60. So the other angle is a 30, so there you have another 30, 60, 90. So across from the 60 you always put square root 3, and across from the 30 degrees you always put 1, and then 2 on the hypotenuse. And then you need a negative on the 1 since we went left, and a negative on the square root 3 since we went down. So those negatives indicate direction. Now you're ready to go through whichever ones you need. Sine, opposite over hypotenuse, negative square root 3 over 2. Cosine, adjacent over hypotenuse, negative 1 over 2. Tangent, opposite over adjacent, negative square root 3 over negative 1, so the negatives cancel, so just positive square root 3. Cosecant, reciprocal of sine, so hypotenuse over opposite, 2 over negative square root 3. Rationalize that, negative 2 square root 3 over 3. Secant, reciprocal of cosine, so hypotenuse over adjacent, 2 over negative 1, so that's negative 2. And cotangent, reciprocal of tangent, adjacent over opposite, negative 1 over negative square root 3, that'll become positive, and 1 over square root 3 rationalizes to square root 3 over 3. Okay, and in the fourth quadrant, so imagine you have to find exact values for 300 degrees. You're going to draw a 300-degree angle in standard position, all the way around, counterclockwise, 300 degrees. And that's going to leave you with 60 degrees left, the 60-degree angle being made with the horizontal. Notice that I didn't draw this to scale very well. It doesn't really look like a 30, 60, 90, but that's okay. It doesn't have to be to scale. Always put the square root 3 across from your 60 and the 1 across from your 30 and the 2 on the hypotenuse. Negative on the square root 3 to indicate direction because we went down. Another mistake I sometimes see people make is they accidentally draw their, once you get your angle and you get your terminal side, then they connect it to the y-axis instead of the x-axis, and they try to use this triangle over here. That doesn't work. Everything's going to be mixed up. So your triangle is always connected to the x-axis, not the y-axis. Okay, once you have your triangle labeled, you're ready to find whatever exact values you need. Sine, opposite over hypotenuse, negative square root 3 over 2. Cosine, adjacent over hypotenuse, 1 over 2. Tangent, opposite over adjacent, negative square root 3 over 1. Cosecant, reciprocal of sine, hypotenuse over opposite, 2 over negative square root 3. Rationalize, negative 2 square root 3 over 3. Secant, reciprocal of cosine, hypotenuse over adjacent, that's 2. And cotangent, reciprocal of tangent, adjacent over opposite, 1 over negative square root 3. Rationalize, negative square root 3 over 3. Okay, so most of the time what will happen is that you won't be finding all of them, but you'll just be finding some, just whatever ones you happen to be given. So let's say you're asked to find the tangent of 120. So what you'll do is you'll draw the picture, make a sketch, locate your 120-degree angle, and then whether or not you label the 120 here is up to you, but you should realize at this point that you have 60 degrees in the triangle right there. And once you have that, you know that across from the 60 you can put the square root 3, and then on the short leg you can put the 1, and on the hypotenuse you can put the 2, and then put the negative on the 1 to show that you're going left. And then from there, opposite over adjacent would be negative square root 3. So that's how you just do it in isolation. Still draw the picture and just figure out the one you need. You can also use this technique if you have an angle that's greater than 360. Like, say for example, we're asked to find the tangent, or maybe not the tangent, let's do a different one. Let's say we're asked to find the secant of, I don't know, 420 degrees. Well, what does a 420-degree angle look like? You're going to have to start on the initial side there, go all the way around the circle once, which is 360, and then another 60 to get to 420. So basically, you're in the same position as you would be in for a 60. It's coterminal with 60. So the secant of 420 is going to be exactly the same as the secant of 60. Label your triangle. square root 3 across from the 60, 1 on the short leg, 2 on the hypotenuse, and then secant would be hypotenuse over adjacent, so you would end up with 2. Okay, so that's how we compute the exact values for 60-degree reference angles.